Okay, then today we are going to do the Matlab assignment 4 together. Okay, so then here, then currently we have the inflation rates as regressors, but we don't need them. Okay, right? In this assignment, right? Right, we don't need inflation rates, right? And then so this should be 3, I think, right? Right. Okay, so then this dependent variable, independent variable, so this is full sample, right? This is the full sample. And then this is the data that will be used for regressors, right? And then this is the regressor that will be used for forecasting, right? And then I consider the to consider interception, we added here 1, right? And then this the first column of X is Korean interest rate, the second column is the US interest rate. And then so this is independent variables, and this independent variable will be used for justification and get the posterior distribution of the parameters, right? Not, and then using the parameters, we are going to forecast future values. And then here is the realized dependent variable. And then this is the dependent variable that will be used for estimation or just the sampling the posterior distributions of the parameters, right? And then once y and x and what yes, this independent variables at for forecasting 1 period ahead depreciation rates, right? Then here there are nothing to change, right? This part nothing to change once y and x here x captive plus 1 are given, right? We are not going to change the priors, right? And then once we have the posterior distribution, once we have the predictive posterior distributions, then we can have its mean and variance, and then we are going to compute its density at the realized value, right? And then we are going to take log. We will repeat this for the recent 12 months, right? Okay, so then once we change the values for the y x captive plus 1 and here realize yf, then this process will be repeated, right? Nothing to change, right? Okay, that's what we are understanding about this code, right? So then let me show you how to do this. Okay, again, this is a full sample. Okay, now because we are supposed to repeat very similar works, then it would be better to use for loop, right? For loop, for, and here, yes, just end. Okay, we don't need, for now we don't need this sort of the displays. Okay, for loop here, say here itr say this is itr I say out of sample forecasting. Okay, 1 to 12, right? 1 to 12. Okay, and then this is not looking good here. Okay, then Control R, and then here right button of your mouse, then you will see the smart indent. smart indent, right? So then this is better, and this, by doing this, you can see the where this for loop start and it ends, right? Then here currently this part is for what? This part is for forecasting the most recent value, right? The most recent value, which is January 2012, right? January 2012. And then I wanna put this ITR OSF start 1, and 1 means the most recent. This 1 means the first one. This 1 means that when this ITR OSF equals 1, then I wanna forecast the most recent month, right? January 2012. And if when this ITR OLS is equals to 2, then I wanna forecast the second recent outcomes the second recent realization, which is what the December 2011, so, right? So then right, so here then ND minus 2, right? So then here needs to be ITR underbar OSF minus 1, right? Why? Because ITR OSF is 1. This is ND minus 1 and minus 1. Now this is 2, minus 2, right? This is minus 2. It should be minus 2, right? It should be minus 2. And if the ITR OSF is 2, then this ND minus 3 like this, right? And starting point is fixed, okay? Starting point is fixed. So then this ND minus 1 here, that means this is simply just ITR OSF, right? OSF, okay, OSF. I always put a space between my plus or minus here, okay? And then here there's nothing to change, right? What about this here? Yeah, this X is from here, right? So there's nothing to change either, right? X, yeah, just X is redefined by adding this interceptor, right? So nothing to change, right? Here Y0, right? Okay. Yeah. Just before I forget, you should not put this here x0 like this, okay, right? And then y0 here, okay. You can see that this y0 and x0 never change within this for loop, right? y0 and x0 are fixed, right? So x is from x0, y is from y0. Of course, this realized underbar yf is from this y0, so, right? Whatever ITR OSF is, this x0 and y0 do not change, right? Okay, right? So that by changing the ITR OSF, you get the different size of in samples, right? And different values of the these regressors and realize YF, right? Okay. Of course, as ITR OSF increases, you will get smaller data or smaller size of the data, right? Because sample series because the sample period will be shorter, right? Because yeah, we are going back to the past, by increasing ITR OSF, right? Okay. So in this exercise, the order doesn't matter. The order doesn't matter, right? Sequence doesn't matter either, right? All right. Okay. So then nothing to change here. Nothing to change. Nothing to change here. Yes. Here. Yes. We have to save the log posterior predictive density, right? Log PPD, right? So then let me save. And to save this, let me make a storage first. Okay. Okay. And then PPL equals zeros 12,1. Okay. Then here this is what? Oh, sorry. Here ITR underbar OSF equals here log. And then do we need this parenthesis? No, it's right. Okay. And then let me put this log PPL, and here's ln PPL. We don't need this log here. Just yeah. Right. Okay, then is there anything to change? No, I don't think so. Right. Let me run it now. Let's run. Okay, let me stop here. Control C. Okay, you can see, and then I want to see is this code is really running, or the how fast it's running. So then I want to put this CLC here, DISP here, current iteration or current ITR underbar OSF equals comma num2 string here ITR underbar OSF, right? Oh, wait, brackets and parentheses. And then just for fun here, just okay, be patient. Be patient. Your computer is working hard. Okay. Oh no, I don't need it. Yeah. Alright. Now let me run it. Let's see. So really this my computer is running or sorry, they're working hard or not. Why I cannot see anything? Again, this is because of the okay here. Oops. Okay, I have to put some space here, and then where is an error? Okay, let me run this again. Okay, in the second iteration there is an error. Why? Here, line 19. Line 19 is here. Okay, and X and Y, or B0 and beta 0. Okay, so then let's see the size of X. Okay, size of y. Okay, here we go. X is 193 by 3 and y is 94 by 1, right? So that's why this multiplication can't be done, right? So this number and this number should be the same, right? Here x is from here, okay, and sorry, here and minus not it's not and minus y itr underbar osf, right? What about this? Okay. What about this? Minus itr underbar osf plus 1, right? Plus 1, yeah, right. Okay, now let's run this again. Yeah, it's working, right? Yeah, I'm supposed to report there's the sum of the log ppds, right? It is, right? Okay, so then let me define this ppdm, log ppdm, and log ppdm, and log ppl is the sum of log ppdm, right? Okay. Okay. Log ppds. Okay. Here this is log ppl. Right? Yes, log ppl is minus 33 5122 here, right? Of course, yeah. Please note that these numbers can be different from yours, right? As long as this number is the same, then there's no problem, right? Because there must be some numerical errors, or the numerical you see, it must be numerical approximation. There must be numerical approximation errors. Okay. Let me show you how much it can be, right? Let's think of the standard normal distribution. What's the mean of the standard normal distribution? Analytically or theoretically, it's a zero, exactly zero. But in here we are using numerical approximation. Okay. Then there must be an error, right? Okay. So then let's think of the let's take a look at here. Rand n 1000, 1. So this is what? This is normal samples from standard normals. Okay, 1000 samples. Its mean is what? Its mean. Theoretically, it should be 0, but here this can't be exactly 0. Okay, let me try again. And right, and let me get another 1000 rows, right? So you can see this is quite close to 0, but this is 0.05, but hey, this is minus 0.05, right? So then the numbers can be different by these small amounts, right? So then as long as your points your value is very close to minus 33, then it's fine. Okay, it could be it could be minus 34 or minus just exactly minus 33, right? Okay, right. Okay, so then this is the this is for model 1, and let's do this for model 2, and let me save as for model 2 here, model 2. So model 2. Okay, in model 2 we use the cross-country interest rate differential, right? Korea minus US, right? And then anything else? Anything else here, right? This should be what? This should be 1 minus x on the bar cap t 2, right? Right? And then anything else? No, I don't think so, right? Okay, let me run this. Yeah, it's running. Oh, here's typo. Your computer. Yeah. Here minus 33.6852, right? So then quite similar, right? Model 1 and 2 are performing very similarly, right? And then so this is the result from the model 2, and then let's try the model 3, in which there is no independent variables. Then you can do this by changing your prior, right? Let's say 0.0000000001, okay, or 2 more zeros. Yeah, it doesn't matter. Okay, let me try. Okay, let's run this again. Yeah, similar, right? Quite similar, right? So then you can see that in forecasting depreciation rate or exchange rate, so then the 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 performance of the models 1 and 2 are very similar to this very ad hoc model, right? So in this model here, there's no regressors, right? There's no regressors, right? So then even if you use the interest rate as a predictors, then they do not improve. These interest rate data do not improve the predictive accuracy, right? So that's so empirically you can see that how much difficult the forecasting the exchange rate is, right? Okay, you might believe that the current interest rate must have some information about the future exchange rate, then actually it's not. Okay. Yeah. Yeah, actually these macro variables have very little information about the future exchange rate, right? Okay. All right. So then I think, yeah, we are done. And please let me know if you have any questions. Okay. Again, so your numbers in here could be quite different from mine. Okay. That's pretty normal and usual. Okay. All right.